Hello, Algebra 2. We are going to talk about Chapter 2, Section 3 today, which is all about rate of change and slope. And our goals today are to find the rate of change and to determine the slope of a line. So rate of change doesn't necessarily have to deal with a graph per se. It could be of a situation. But the slope of a line, that is always having to do with a graph of a line. So, a quick definition officially of what rate of change is. This is the ratio that compares how much one quantity changes relative to the change in another quantity. Any quantities, and typically we put the dependent variable compared to the independent variable. Typically our independent variable, it's independent because we aren't so much dictating how it changes. It just changes on its own. And as the independent variable is going along doing its thing, we have a result of the dependent variable changing as well. So like a good example of an independent variable is time. We don't really set the time, but as time goes along, other stuff changes, for example. And sometimes you'll see this notation, and it might look right now like triangle Y, triangle X, but this little symbol here, this little triangle, is actually a Greek letter delta. It's the Greek letter for D, it makes the D sound, but what it means in a mathematical context is the change in, or the difference in, delta D, the difference, hooray. So this is the difference in, or the change in. So change in Y over change in X. That is our ratio. So let's take a look at a chemistry example. Here we go. The table below shows the temperature for a solution after it has been removed from a heat source. Find the rate of change in temperature for the solution. So I have the chart all filled in there. Go ahead and fill that in on yours as well. So maybe you're doing this experiment and you collect this data and you want to know, well, how quickly is it heating up, cooling down? Let's take a look. I notice as time goes on, and remember I said time is usually a really good indicator of an independent variable, typically, because we didn't say, okay, 12 minutes, go. We just let it happen, type of thing. As the time is going along doing its thing, the temperature is changing dependent upon the time. So there's a lot of options here. We really only need two slots for this. So I'm just going to pick this first one because I like working with 0, and I'm going to pick the last one as well, this set of data and this set of data, to get my ratio of the comparison. So like I said, it's usually dependent to independent. So dependent, the change here is 143.6 degrees Celsius to 118.4 degrees Celsius. If I subtract them, that's going to give me the change. Ratio, so I'm going to divide. Now I need the change in the time, because that is my independent variable next. Well, at 143.6 degrees Celsius, that happened at 0 minutes. And I'm going to take away from that 12 minutes. And I'm going to get a negative, but that kind of makes sense, right? We see that the temperature is decreasing as time goes on, and that makes sense, right? If the heat source is gone, the solution is going to start getting colder minute by minute. So let's see what happens here. Just so I get my right number, we have 143.6, and I'm going to subtract 118.4. 25.2 degrees Celsius is the change there. And then I already see this is going to be negative 12 minutes. Negative time generally isn't a thing. However, this is going to just become a negative answer overall in a minute. So what I'm going to do is just divide this through. So I have 25.2, and I'm going to divide that by negative 12. I get negative 2.1. So my overall answer is negative 2.1. But negative 2.1 what? That is the question. So I'm going to use the units that I used in my ratio right here. That is degrees Celsius per minute. So every minute it is decreasing 2.1 degrees Celsius. So that negative sign is telling us this situation is decreasing. So the slope is negative. There we go. Okay, so that's example 1. So that's just the rate of change of a chemistry situation. Well, let's take a look at a chart, see what we can do with this one, a graph. Refer to the graph below. Find the average rate of change of the percent of total music sales for both CDs and downloads from 2001 to 2008. Compare the rates. I did want to say one thing real quick about this last one. This is what we call a constant rate of change. Notice real quick, if I picked another number, so let's say I did 143.6 minus 133.1, all over 0 minus 5. And I'm doing this a lot quicker because I know that you guys can do this calculation. I get 10.5 divided by negative 5. Notice I get negative 2.1 again. Degrees Celsius per minute. This is what we call a constant slope. Because, and you would see if you picked any of these numbers, it's going to be negative 2.1 all the way around. However, this one, we see the slope is very much not consistent. It's not constant. This is a varying slope. It goes up a little, down a little, up, down, 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 down. This one's going up slowly but surely. So average is the key here. Average. My answer might be different than the answer you might have gotten, because what we're going to do is just really, we could pick any point we wanted. However, we want to make sure that we pick representative points to find this rate of change. Notice on this particular graph, they've only given us the end points of both graphs. So we're just going to use those. We're just going to use those. Use your resources. So here we go. I see in, it looks like 2001, and then in 2008. In 2001, I'm going to work with the CDs first. Again, my independent variable is going to be time. And really that's my X as well, is the year. My dependent variable is going to be the percentage of these sales. So here we go. I'm going to do change in the dependent variable divided by change in the independent variable. We have for the CDs 89.2% minus 77.8%, and that is all over 2001 minus 2008. Okay, 89.2 minus 77.8. I get 11.4% divided by negative 7, and really I should say this is the year, this is the year, so this is 7 years have passed. So if I do 11.4 divided by negative 7, I get kind of a gross number, but I'm just going to give a couple places. So this is negative 1.63 roughly percent per year. So the CD sales are decreasing, that negative is decreasing, 1.63% per year. Now let's take a look at the downloads. Again, my dependent variable is the percentage. I'm going from 0.2%. Now I'm increasing. I see that to 12.8%, all over 2001 minus 2008. That's still negative 7 years. Well, 7 years have passed. And then 0.2 minus 12.8, I get negative 12.6%. When I divide, I get 1.8% per year. But notice this was a negative divided by a negative. Therefore, I'm going to get a positive as my answer. That is important here. So we already dealt with in example 1 and right here the fact that decreasing is implied by the negative. But for this one, I have a positive, meaning this is increasing. So the question referred to the graph, find the average rate of change of the percent total music sales for both CDs, downloads, compare the rates. So just make a little statement about what you see the differences between them. You might say something like, CD sales are decreasing and download sales are increasing. Just a quick little statement like that. That's all you need to say as a comparison. Okay, and then real quick, we are going to go to officially slope, which is on a graph with ordered pairs. So here we go. Slope is the ratio of the change of the y-coordinate to the corresponding change in the x-coordinate, the rate of change of a line. The equation, I'm sure you know it. Usually we say that it is m. Why we use m, I do not know. But m is our slope, and it is y2 minus y1 all over x2 minus x1, which is what I was doing up top for the other examples. Anyway, so that's my difference. So real quick, find the slope of the line that passes through -4, 3, and 2, 5. You can do this one. Take a look. What do you get? What is the slope? And let's do it now. So we have 3 minus 5 over -4 minus 2. That gives me -2 over -6, which is a lovely 1/3. And you can switch that if you want to. If you had done 5 minus 3, 2 minus -4, don't drop that negative, you get 2 over 6, which is still positive 1/3. So it does not matter as long as you are consistent. The 5 and 2 have to be with each other. The 3 and the -4 have to be with each other. And example 4, find the slope of the line graphed below. So again, try this one. Pick some points. What is the slope? And let's take a look now. Really, you can pick any point you see on this graph. I would recommend picking nice points. When I say nice, I mean ones that happen at nice crosshair intersections. So I see one right there. That looks like it's at 1, 1. And I see, this one looks pretty nice. That one looks like it's at about -1, 0. When I do my slope, I'm going to have 1 minus 0. I love working with 0. Minus -1, I get 1 over 2. No further simplifying needed. There we go. And if either of these had been able to be reduced, you would have done that at that time. So let's say you had your slope, maybe instead of those points, if you had picked this point instead, -3, -1. So if you had done 1 minus -1 over, so 1 minus -1, 1 minus -3, you would have gotten 2 over 4, and that is able to be reduced. You would reduce that to the 1/2 that I got the first time. There we go. So that is all about rate of change and slope, and I'm sure you guys knew a lot of that already, but just dusting off some cobwebs. So there you go. We will talk about this in class shortly.